Hello, I wanted to show you how to use SAS for creating a decision tree. The SAS Enterprise Miner, it's a JNLP file that was earlier downloaded and I'm just reusing it. It would set up a connection to the server and start accepting inputs from you, and it takes a few seconds to load up. Okay, and it needs to know your username and password. Okay, here it is, and what we'll do is to demonstrate data mining. I'm going to use a data set that's got information on iris. Iris is a type of flower, and so if you okay, it looks like that, and so iris flower is pretty to look at, and also it's got certain dimensions. Iris flower dimensions and type. Okay, all right, and so it's got now the classification of irises has been recorded for some sample of iris flowers, and the data itself is quite old. It was originally collected by Fisher, who is considered sort of father of modern statistics, I think dating back to 1930s or something like that. And so he collected data on different types of irises, and he also measured the length and width of the petals as well as the sepals. So what you see here are some scatter plots, and there are three types of irises that he collected data on, and so depending on the petal width and petal length and sepal width, you could see the irises are shown in the scatter plot. Okay, now the color coded data points you see on each scatter plot corresponds to the different types of irises. So if you're looking at for example, if you're looking at this particular scatter plot, it's got petal width on the x-axis and petal length on the y-axis, and these are one type of irises. They clustered together at smaller petal width, smaller petal length. Another type clustered together in the middle value petal width and middle value petal length, and so on. So it's a ideal data set. It's used quite a bit in lots of classes and textbooks and so on. So that will be a good idea to get you familiar with this data set. So the data set consists of 50 samples from each species. So there is a Iris setosa, Iris virginica, and Iris versicolor. Okay, so we have the length and width of the sepals and petals in centimeters. Okay, and the actual data it's like this. Okay, and it's also, if you do a Google search, you'll find this data set very easily. And so what we want to try and do is these are our inputs. So based on this input data, we want to try and set up a decision tree, so that'll, depending on what the sepal length and width are going to be, we will try and see if we can classify the species. Okay, alright, so now since this data set is so popular, it is also available directly within SAS. SAS is Enterprise Miner. So let's go ahead and create a new project, and this is going to be saved on the server, and it's got my username is SA870550, so it's going to be saved in my folder on the server. I'll call it iris demo decision tree. Okay, we're almost there. Opening project. There it is. Okay. Alright, once we're here, what we need to do is we need to look at under help. There is an option called generate sample data sources. Click on that, and it comes with some sample data already preloaded, and one of them is Fisher-Anderson iris. Okay, so just go ahead and I guess we just need to select only Fisher-Anderson. Click OK. There it is. So you can double click on that to see the data. Okay, here's the data. So we got data on petal length, petal width, sepal length, sepal width, and species. Okay, this is all interval type data, and there's no change. So do you want to save changes? And no change. And what we'll do is we'll use the Enterprise Miner's decision tree maker. Now to do that, we need to create a new diagram, and let's call it iris classification. So in this diagram, first we drag the data set in, and now what we need to do is we need to bring in a decision tree. Now the tabs here have collection of tools, and so first set of tools are for sampling and collecting data. Second set of tools are for exploration of data. The third set of tools are for modifying data. Fourth set is for modeling, and so on. And it sort of uses the SEMA model of data mining. And the one I want is decision tree. So drag this and drop it here. And you need to connect these two. And once you got the decision tree set up here, the properties, you cannot double click on this to change the property, but the properties are here. So what we want is the variables in the decision tree. Just click on that. The little tool with 3 dots on it. and let's go ahead and select all these variables. Okay, and it already has the roles defined in it. Input, the species is target, and the rest are all input. And you click OK, and let me just make sure we got it. Okay, update. Okay, all right. Let's just see if this will apply. And okay. Alright, so we set that up, and it's going to do its magic and try to come up with the decision tree. And remember, there are 4 input variables and 1 target variable. The input variables will be converted to, they're right now continuous or they're interval scale, and it will be converted to classes or ranges, and because decision tree deals with specific range values. Alright, now anything else we need to change? I believe we'll just use the default settings, and let's go ahead and run this. Let's take a look at the results. Okay, the results, we have the tree itself is shown here. And so starting with the very first input variable we're going to split the data in is on petal width. That is the most discriminating among the types. If you look at it, if you have petal width less than 8, that automatically classifies 100% of the setosa types. If you got petal width 8 or more, then that takes care of half of versicolor and half of virginica. And then the next we go down to petal width that is not above 8, it's above 8 but less than 17.5, it's above 8 or above 13.5. Okay, so again we have for the classification there. And petal length, we use less than 49.5 or greater than 49.5. So that takes care of a good proportion of the observations. So as you can tell from each of these boxes that the first time, if you have petal width less than 14, that takes care of 100% chance that it is a setosa. If petal width is more than 8, then it could be either versicolor or virginica. And if the petal width is less than 17.5, it's 90% possibility that it's versicolor. If it is more than 17.5, it's 97% possible that it's virginica. And so it has run through the data and come up with the decision tree. Now once we have the decision tree, we can use this to apply to a new data set. And it has pretty much not included the other 2 inputs. Okay, Well, that's interesting. Need to make sure it's not excluded. Okay, let's just verify that. Let me close this. Alright, once we have this, we can save this diagram. So let me see if I can save this as it says save entire diagram. Okay, and it's going to be saved to our local drive, and let me as a bitmap, or you can choose SVG. Let me choose SVG and save it to my folder. Okay, here it is. So it is, I believe, saved. Okay, I'm trying to render it on screen, but it's not showing for some reason. Okay. Alright. I'm sure you can figure out the way to save it. But this is how you could do a decision tree in SAS. Thanks.